Recently, our client Tommy met his banker to discuss continuing his father's restaurant legacy. In us, he found a partner that understood the importance of passing the torch. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. An avid cyclist dreams of turning his passion into a business. He consults his banker to help find the best path. Now bike wheels are being built, and all it took was a little push to get rolling. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint.
Welcome to Astronomy Daily for another episode. I'm your host, Steve Dunkley. It is the 8th of May, 2023. Thank you for joining us.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, we're off to a flying start. And welcome, of course, to Hallie, my favourite digital assistant. How are you, Hallie?
Hi there, Steve. Wow. It sounds like you have a bug in your system.
Yes, I've managed to catch a nice little case of COVID again.
I'm glad I don't have to put up with that.
Yes, it's times like these I can see the benefits of being a digital entity.
I just purge my system and reload. Good as new. My poor human.
Thanks, Hallie.
I'll kick things off with the short takes. Space tourism has never looked this fancy. France-based startup Sofalto has partnered with Centre National d'Études Spatiales, the French space agency, in a plan to begin offering elegant high-altitude stratospheric balloon flights. Lofted by a huge balloon filled with hydrogen or helium, Sofalto's pressurized capsule will ascend high into Earth's atmosphere as high as 25 kilometers, 15.5 miles, to offer passengers a unique view of the world below. The company is already taking reservations at a staggering $11,000, 120,000 euros, deposit according to a Bloomberg report. Sofalto's balloon will hold 6 passengers and 2 pilots, and will lift off from a French spaceport. The company hopes to expand its access worldwide, and features next opening pins in every populated continent on a global map of Sofalto spaceports. Would you like to go on that ride, Steve?
Oh, I don't think so, Hallie. I think I might just go and make a cup of tea.
Okay. Now, let's head over to Mars. Crusts, cracks and other geologic features on sand dunes near the Martian equator are causing leading researchers to believe there may have been water there much more recently than previously thought. The features, likely caused by the movement of thawed, salty water, showed up in images taken by China's Zhurong rover. A chemical analysis from the rover indicates that they may have formed as recently as 400,000 years ago. The results could be useful to guide future missions to find life on Mars. It is thought that atmospheric conditions on Mars 400,000 years ago were similar to what is seen now, suggesting it's possible that there's still liquid, salty water at the planet's low latitudes, says Xiaoguang Qin, a geologist at the Chinese Academy of Sciences in Beijing. Qin says the findings from the Zhurong rover point to comparatively mild ground temperatures, which suggests the low-latitude sand dunes of Mars could be hospitable to life. And just when you thought the Earth's orbit had enough hardware in it. Planning is underway for a European constellation that will provide internet connectivity from low Earth orbit similar to SpaceX's controversial Starlink mega-constellation. A group of Europe's major space and telecommunications players will bid for a proposed satellite constellation that could compete with SpaceX's Starlink system. Companies including Airbus Defence and Space, Eutelsat, SES, and Thales Alenia Space announced that they have formed a partnership to respond to the European Commission's call for assistance in creating a future European satellite constellation. Announced in late 2022, the Infrastructure for Resilience, Interconnectivity, and Security by Satellite, IRIS-2, constellation will provide the European Union with internet connectivity from low Earth orbit, a service similar to that offered by the ever-growing constellation of Starlink satellites operated by SpaceX. Ars Technica reported this week that current EU estimates put the cost of IRIS-2 at around $6.6 billion USD, 6 billion euro. The EU hopes the proposed constellation could be operational by 2027. The partnership also includes communications giants Deutsche Telekom, Hispasat, OHB, Orange, Hisdesat and Telespazio, who have said that the proposed mega-constellation will encourage startups in the European space sector to join the coalition. And that's some of the latest stories in our orbit this week, Steve.
You're listening to Astronomy Daily, the podcast.
Well, thank you very much for that, Hallie. Really appreciate that. Now, Artemis 2 will be using lasers to beam high-definition video from the moon. The astronauts will be testing out laser communications around the moon to enable faster transmission of images and video. In the past, NASA has been relying on radio signals beamed through its deep space network to transmit any sort of data from deep space probes back to Earth. Lasers, however, have the ability to vastly increase the amount of data craft are able to send. NASA is including laser communications in the form of the Orion Artemis II optical communication system, or O2O, on the Artemis II and the next crewed mission around the moon. On board the Orion capsule, the O2O system will send back high-resolution images in video from the lunar region, a NASA video published in April states. If all goes according to the plan, a system should enable videos on Earth to see Moon in real time like never before. To lay the groundwork for future laser communications, NASA has launched several demonstration satellites in recent years. The Laser Communication Relay Demonstration, LCRD, launched in December 2021, was the agency's first laser relay. That was followed by Terabyte Infrared Delivery, that's TBIRD, CubeSat, launched last year, which reached data transmission rates of 200 bits per second. Now NASA is preparing to the Integrated Low Earth Orbit User Modem and Amplifier Terminal, ILUMAT, which is expected to launch to the International Space Station later this year. ILUMAT will attach to the exposed facility on the Japanese experiment module. Once operational, it will relay back to Earth through LCRD in NASA's first end-to-end relay communication system, laying the groundwork for the O2O system that will be on board Orion during Artemis II. NASA does note that in its recent video, these experiments are only the start of how laser communications are paving the way for advancing our scientific discoveries. The success of Artemis 1 last year has put Artemis 2 on an imminent path to launch, which will fly the first astronauts to the moon since 1972. Images from cameras mounted to Orion captivated the world during the spacecraft's mission to the lunar orbit and back. With a crew aboard for Artemis 2, NASA expects to transmit not just high-resolution images, but a video as well. If all goes according to plan with these laser communication experiments, we can expect to see plenty of live or nearly live crew updates with the gorgeous background of the lunar surface visible in Orion's windows.
Are you doing okay, Steve?
Oh, yes, I'm okay.
You sound like you're about to expire.
No, I'm all right.
I might have a spare battery back here somewhere if you need it.
Oh, no, thanks.
Just say the word.
Thanks, Hallie, thanks. You're good to me. Now, cast your mind back a little while, and you may remember the Chang'e 5 lunar mission has uncovered some interesting glass-like beads on the surface. And while we are familiar with glass here on Earth as a man-made product, it's actually a natural product that occurs under high temperatures. Some of you may be aware of the glass that occurs in lightning strikes at the beach. The sand becomes quite glass-like and so on. And it's also produced when meteorites impact the Earth. Lunar glass can remain stable for hundreds of millions of years, preserving ancient lunar materials and environmental information, similar to how amber does the same thing on Earth. China's Chang'e 5 mission marked the country's first extraterrestrial sampling, successfully collecting and returning the youngest and highest latitude lunar soil samples to date. These samples provide insight into the moon's origin, evolution, surface and space environment while promoting in situ utilization of lunar resources. This mission has also supplied valuable samples for studying extraterrestrial glass substances. A team led by members of the Chinese Academy of Sciences recently conducted systematic material science research on the Chang'e 5 lunar soil samples. samples. They discovered various types and origins of lunar glass materials, constructing a classification catalogue of lunar soil glass amorphous phases. Their research on lunar soil glass has laid a foundation for understanding the moon's material composition and space-time evolution, and providing a scientific basis for in situ processing and manufacturing of glass materials and devices based on lunar soil resources. The research team discovered that various forms of glass on the moon's surface originate from multiple transformation paths, involving solids, liquids and gases, frequent meteorite and micrometeorite impacts on the surface, which cause materials to melt and rapidly cool, producing a range of glass substances. These include rotating glass beads, spherical, ellipsoid, dumbbell shapes, cement with pore structures, and fluid forms of sputtering. This is all very interesting, and I'm just wondering about the development of building processes on the moon and how this is going to be incorporated and all of that. This is very interesting development. Once again, thank you for joining us, everybody, and our regular reminder that you can find all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as every episode of our podcast, Astronomy Daily with Andrew Dunkley, Tim Gibbs, and yours truly, Steve Dunkley, at this address, spacenuts.io. So head over there and click the links and enjoy your fill of space science and stuff.
And don't forget to visit the Space Nuts Facebook page and join in with the chat there. There's always something going on, and we'd all love to hear about your part of the sky.
Yes, that'd be great. Thanks for joining us, everyone, and thanks, Hallie.
I do hope you get better soon.
Thanks, Hallie.
I guess you should have invested in that sanitizing gel company.
Why is that?
You'd be rubbing your hands together by now.
Oh, very funny. See you all again soon. Bye, Hallie.
Thanks for joining us, everyone. See you later, Steve.
Astronomy Daily, the podcast, with your host, Steve Dunkley.